All right. Hello, everyone. Let me see. Okay. Hi, everyone. It seems that we're live. It's Nono here, and I want to welcome you to my live stream. If you're new, if you're connecting for the first time, this is a live stream where we take a look at things that have to do with creative coding, machine learning, art and design, podcasting, sketching, many different things. I try to reserve a weekly hour or a couple of hours every week to do some coding that has to do with these topics, maybe also some Q&A, and I'm trying to figure out how to also make it something that people who don't know how to code can follow, or people who are getting started, for beginners. I've heard some of your questions and some of your requests, and it seems that, of course, if we get into the weeds of machine learning and complicated algorithms or advanced coding for machine learning, it's a bit hard to follow. So I'm listening, and I would be willing to do some more introductory tutorials, even live streams, and upload videos so everyone can keep up. But the only thing I would say is that thanks so much for these comments and for this feedback, because it's really useful and it's really going to inform the contents of the live stream and the things that we do here. Before as I continue talking, I would like to get a confirmation that you can hear me and then you can see me okay, and that everything is being streamed properly. So I'll get started. So let me know in the chat if there's something that is not working well, or if you can hear me properly. All right. So this is the live stream, right? As I said. And the only thing I will tell you before we get started is that if you like the video, you're helping support the channel, and this makes other people to have an easier time finding the channel and finding our content. So this is something that we're building together, so I would really thank you if you do that. And in case that you want to be notified when I go live next, or when I upload new videos, go and click on subscribe and click on the bell to receive the notifications. Right, the community keeps growing. I'm thankful for all the people who are joining and the people who are interested on joining this community. You can join at Nono.MA/Discord. It's an open Discord server, and we can chat there. As a recap, over the past month, we've been taking a look at things that have to do with StyleGAN and also sketch detection or object detection. We've trained StyleGAN models live. We've seen how to generate images, but we're going to continue there. And we've also done live Q&A. You can submit your questions at gettingsimple.com/ask. I'll remind of that link in a few slides. And now we have this convention where you can see here that we have those links at Nono.MA/live. If you put a slash and then the number of the live stream, you will go to the video. So when I refer to live 24, live 23, live 18, those links will work, but I need to go back and make the links work from 1 to 20, I think, still. So for the last weeks, this is working, and the live stream you're watching right now is at Nono.MA/live/25. You can check that on your computer, on your cell phone. This makes it easier for you to access the live stream, for example, on your phone, if you don't know how to look for the link, or if you want to switch to the computer or something like that. That was StyleGAN. We also saw StyleGAN and object detection live 23. We actually only saw how to refactor the StyleGAN notebook. Live 18 also revisits a bit of the hallucinating sketches and portraits. And live 22 is where we looked at how to label an object detection dataset. I want to step back for a second. Hello, Mamadou Kali. Nice to see you here. Nice to see some familiar faces. Thanks for chatting and for being there. I also uploaded, this is a quick announcement, I uploaded a new episode that I've recorded this week at Getting Simple. So this is episode 45. It's about looping playlists. This doesn't have anything to do with machine learning, just practice that I do to focus by listening to playlists that have, top 45 minutes or so in length, like maybe 5 to 10 songs. So if you're interested, you can go there, Getting Simple, and you can listen to it. Maybe give me some feedback or comments. What are we going to do today? So I am going to try to revisit some of the things we've done with StyleGAN. We're going to go straight into generating images. and we'll see what else we're gonna do. We have these topics, and one of the things that I want to reiterate is that the live stream is not only gonna be about machine learning, but it's what we're gonna be focusing on now. I need to do a bit more preparing on the topics that we're gonna cover, and also get verification from you that that's something that interests you. But we'll be looking at, kind of jumping between things. Lately, we haven't had a lot of time, and we've been mainly focused on StyleGAN, which, I don't think that's necessarily bad. I think it's pretty cool how far we've got. All right, so last reminder, gettingsimple.com/ask. You can go there, you can click start recording, and then you can use your phone's microphone or your computer's microphone to submit a question. If you don't want to do that, you can click on submit a written question. You can just type your question and it serves the same. But if you click on start recording and send a voice note, I might include that on the live stream as audio, as we did last week, or as audio on the podcast, and actually reply on a podcast episode. Cool. So training StyleGAN in Collab and generating images with StyleGAN. These are the main things that we're going to do today. So let's go back to that. Training StyleGAN in Collab. We did take a look at this. Let me just see if I can switch screens quickly. Yes. We took a look at this the past week. So I'm going to remind everyone who's watching that if you go to the chat channel on the Discord server, you're going to find links that are relevant to each of the live streams. So for example, here we have links for live 24, and I tend to put these ones live so you can follow along. And let me put this aside. Also, if you feel that the live stream is good, the quality and the sound, let me know, because YouTube is telling me that the bitrate is a bit lower than it should. And I feel that everything is going good, but I don't know. So just let me know if you can hear me okay. All right. So let me get here. Okay. So we have these links. So if I go here, one thing that I realized is that right now I have these notebooks on my Google Drive account, but we could potentially send them or like push them to the live repo on GitHub. So if you go to github.com/nono.MA, I have the live repo, and I'm trying to put as much code as we have, or as much files as we have related to the exercise we do on the live stream. You can see I'm not doing like a super good job, but we probably should do some of that. So this was live 24, and what I want to try to do is so let's see, maybe we can do that as a first exercise. That's like a really quick thing. So we're gonna go, let me see if I have here this repo. So this is not the repo, is it? What is this? Okay, these are the files that we've been using on the different live streams. This is not actually the repo. Maybe this is, nope, not live. Okay, this is the repo. So we have a set of folders here, and I'm gonna create the folder 24, and we're gonna make a test. So I have this notebook. We're gonna put here the dark mode again. So I have the notebook, and what we're gonna try to do now is host a file or like a Jupyter Notebook on GitHub, and load it on Google Colab, so anyone can open our notebook. Let me record quickly a title slide here. Loading Jupyter Notebooks in Google Colab from GitHub. Right, so I'm making a quick tutorial for my future self to edit. Let me see where this is. All right. All right. Okay. All right. Cool. So let's just do this really quickly. So okay, here. Hi everyone, it's Nono here, and we're gonna take a quick look at how to load. Wait, where is this? Well, and I see that Ricardo Rodriguez is connecting. I will just give him a highlight. So he has been sharing some of the experiments or the work that he's doing on the Discord server, on the machine learning channel. So this is really interesting, right? Like we're trying to connect different people that are looking at similar problems or different things to experiment with. Ricardo specifically, if I'm not wrong, like he's researching on the field of design, architecture, floor plans, furniture, and many other things that I don't know of yet, but probably maybe learn in the future. He was taking a look this last week at the FI Discord. That's the Frenet. I forgot now the name. Is it here? FID Frenet score. Yeah, Freshet inception distance, which is something we saw with StyleGAN, that the lowest this number is, the more the fake images are generated by a neural network and the real images are. So the lowest, the better. So Ricardo is looking at that. I haven't had time to look at it. There seem to be some libraries that are covering this topic, and hopefully we can take a look at some of those things on the live stream as well. And it's great that we're kind of collaborating in these sort of tasks in some way. Okay, so let's take a look at this. Let's really quickly start, and I'll go here and say, hi everyone, it's Nono here, and this is a quick view of how we can load Jupyter Notebooks from GitHub on Google Colab. That is, Jupyter Notebooks that are hosted on a GitHub repository can be directly opened or shared for somebody to open in Google Colab, and then quickly start and execute. This URL will update every time that you change the notebook on GitHub with the same URL in Google Colab. Let's take a look. All right, where is this? All right, let me just do this. Let's take a look. Can do this. I don't know what's going on. So let's take a look. All right, so we have a GitHub repository here, and we have a Collab Notebook. And what I'm gonna do, just to show that this works, we're going to save a copy of this notebook, or download a copy of this notebook to our computer. So we go here into file, right? So let me just zoom into here. So we go into file, then below here into download, and then download IPYNB. That's the Jupyter Notebook format. You could download also only the Python code. We download the notebook, we open that, and we have that here. So we could open that with Visual Studio Code, for instance. So let's take a look. We can go back to our repository. So I've created folder 0024, and I'm going to put that here. So you can see I can open this folder. And hi Major, nice to see you around. Nice to see you're connecting, and thanks for saying hello. As you know, we've commented before, Major is doing a bunch of live streams as well, machine learning, on like reviewing papers and state-of-the-art algorithms. So I'll really encourage you to go ahead and check out his channel. That's Engineering Architecture, with like, you know, the tech is like TECH. You can see it on the chat comments. All right, so as I was saying, we can open this notebook on our Visual Studio Code, because Visual Studio Code now can open and execute notebooks. We'll have to have the proper Python environment with the dependencies to be able to execute. And this specific notebook has dependencies that we don't have on this machine. I cannot really run it. So we need to run it on Google Colab. Those are specific to GPU plugins that StyleGAN needs to run. So we have this notebook here, and what I'm gonna do, you can see there's a lot of divs here, but I'm just going to go to the div and just add this notebook here. So I'm going to change this and maybe just put here StyleGAN to training v4 live 24. And then the date here. All right, so we have that, and we're gonna add it to commit this, and we're gonna add a commit message here that is gonna be add the StyleGAN to training notebook. I push Command and Enter on Mac, and now, as you can see here, I can do git push origin master. Because I've failed to push. All right. What branch are we on? Oh, we're on the main branch instead of master. All right, so we pushed that, and now if we go to a repo, we have that here, and we have this thing here, right? So we can also preview the notebook on GitHub, and this will open this StyleGAN notebook that we've been using for or like working on for the past 2 or 3 weeks, right? So this is a beautiful notebook, right? It's full of stuff, and we also have the predict one, which we should add here as well. And this might be wrong. Let me just try it. So we can do this maybe here, GitHub/. All right, and that works out of the bat. It does have the name also of the notebook. Okay, so what you can see here is that just by adding the GitHub word, so this is collab.research, let's zoom in here. So the only thing I had to do was to add collab.research.google.com, right? That's the path to the actual file. So this is Nono.MA, that is my username, live is the repository's name, and then this is the actual contents of the main branch, the folder, and the name of the notebook. How can we get to that? I mean, easy. We just open the file, so we see the notebook, we copy this, and actually the only thing we have to do is copy this and remove the .com. Let's try if it works as well with the .com. It doesn't, right? So we will say, okay, google.research.google.com, we paste that URL, remove the .com, and then this works, right? Let's try with a really let's make a really quick test. So if I make like a new branch, I don't even remember. Was it M? Haven't been coding for a few days. Maybe M. So live 24. All right, so I'm in branch 24, and what I'm gonna do is simply create a new Jupyter Notebook. Let's actually just do Jupyter Lab. Right, so we have Jupyter Lab on my machine. I'm gonna create a new notebook. So it's gonna be a Python 3 notebook, and I'm gonna print, this is my new notebook, right? And then I print that, and then I say A equals B plus C, and we define here B is 100, C is 20, and then we print A. All right, so this is our notebook, and we have that in here, it's untitled, and we're gonna call it test notebook. And now we just have to add that. Well, this is test notebook. One good practice, you can see here the IPYMB checkpoints. I don't think we need to commit that, so we can actually go to our other branch, to main, and create a new file. So touch 0024 git ignore, and we're going to add the IPyMB checkpoints, that. So we ignore that, and we're gonna commit that file. Ignore notebook checkpoints. We could probably do that outside, so it ignores all of them. We don't have to create a per subfolder. Let me just try to see if that works. So instead of that, we're gonna take a look in here to the maybe I have a typo here, so maybe that's why it wasn't working. Yeah, maybe. Right, so we're gonna remove this one, we're gonna remove this file, and we're gonna add our change. Right, we push that, we go back to the live 24 branch, and git checkout main. Oh, okay. Git checkout live 24. Okay, git checkout main, git merge live 24. All right. Cool. All right, so we have that now, and now our diff is ignoring all those changes there. And I'm gonna add this test notebook. Add test notebook. We just push and then push to this branch, and now you're gonna be able to see. So I'm gonna stop the Collab. Well, no, let's leave the, well, no, let's actually stop the Jupyter Lab. All right, so we stop the Jupyter Lab. We go to our repo. We can now see this new branch show up in here. So the branch live 24. And now we have this branch, you can also see this train test notebook, right? This test notebook doesn't exist on the main branch, but it's here for test purposes. And I just want to show that if now I change the main keyword here for, I'm gonna make it fail. So again, I copy this path. Well, yeah, I mean, we could just put here test notebook IPYMB, and it's gonna fail because that file doesn't exist, right? But we just need to change the word main for live 24. That is the name of the branch, and then that loads. And again, to do that once again with the URL, we just copy this URL, put it here, remove the .com, and then we have this here. And now we can execute it. It's gonna tell us that it wasn't authored here, that is from GitHub. This is going to connect us to a runtime, And now we have this being executed, right? So what's nice, I mean, if I reload, every time we reload, this is going to reset to default because it's loading from GitHub. So you would have to make a copy by clicking, here, copy to drive. And the nice thing is that now if somebody updates the notebook, so let's say we do here import TensorFlow as TF, and then we print here the TF version. I don't know if you can do this. Maybe you can. I don't know. Well, yeah, I don't know if you can do this, but it will fail later. So we just add it. We say edit notebook. We send this. We push it. And as soon as this goes to GitHub and the file gets updated, we're going to be able to just take a look, right? So there's no TensorFlow anything here. Let's make this bigger. So as soon as I just update, this is going to reload the file from GitHub, and oh, maybe not. Why not? Let's take a look. So on GitHub, reload. Right, so in GitHub, this file is now updated. So I'm gonna reload here. All right, and I'm not sure why this is being cached. So there might be something there that is telling this not to refresh. Okay, maybe this works. Okay, yeah. So this works. We're like getting a file at a specific commit, but ideally we would just be able to do live 24, which is the branch. And after some time, this would eventually update because Google right now has cached that file, so it's not updating it super quickly. But we're loading from here right now. So now we're going to try to execute this, run anyway, and then execute. This might fail. I don't know if this works, if this is valid Python syntax, but we'll see in a second. All right, so this works. So you have TensorFlow 2.4.1. And even if this doesn't execute because we don't have TensorFlow in this environment here locally, I can test it online. So you can be coding things and then test them later or share them, because now anyone who gets to this URL, to this test notebook, is going to be able to run it. Notebook with TensorFlow, blah, blah, blah. And this is, let's just put here, let's test for TensorFlow. All right, so we're gonna rename this file now. Sample notebook. Right, so we add that. Cool, and now we push it. And the only thing I'm going to do is that I'm going to check out main and merge these changes we've done and then push them. So master branch, so to main, and this doesn't exist because we've renamed it. So we're going to click on sample notebook, and now we can copy this address here. So we have the updated thing. You see this is from local, so I put that from my local machine. I could actually clear all cells. And then do that, and I'm actually going to delete the branch we did for today. All right, so that seems like should be updated now. All right, and we're going to load that from Collab. We could actually, just do it here. So you could say collab.research.google.com, and that's it, right? We have it here. We could even, we could even do, this is pretty cool. So let's make like a button to open that with Collab automatically. So the only thing we would need to do that is a bit of JavaScript trickery. So we would do, so we have location, href is the URL. So we would say, so if, so we will put here location, href, and we'll say if location split github.com length is greater than 1, then we'll do something. And then what we're gonna do is that we're gonna redirect our website to, or like open a window. So window open https collab.research. Let me just make this a bit bigger so you can read it. Oh, hello, Bea. I see that some familiar faces also on the chat. And Majur was asking, well, yeah, I really appreciate you sharing some of your stuff also on the Discord server, Majur. And Majur is asking, is the Jupyter Notebook hosted directly from GitHub or a local instance is created in Collab? I do think it's created on GitHub. And then when you click, you have that option that shows up in here, which is to copy the file to your drive, and that way it will be saved on Google Drive. But until I copy it, we're just loading an instance on a temporary machine or a temporary notebook, and the notebook is hosted on GitHub. All right, so we have this, we're trying to do this, and we're gonna do collab.research.google.com / GitHub, and then we'll load here location split github.com, and then the second part of this argument. All right, let's say location has already been declared. All right, location already exists, so we don't really need this variable. So location href Awesome. All right, so this works, this code works now. So what we're gonna do now, we just need to add, I have another button here. We just need to add the document, so just JavaScript at the beginning. All right, so what we do here to create a button here is we just save whatever, we go to edit, and now in here we say open in Collab, right? Or we could do, yeah, like GitHub to Collab or something. I'm just gonna put this thing here, and I will just do here JavaScript and then put that script, and that's it. So we just have that. Let me just go back, save. So how this works now is I have this notebook. Let me just close everything else. So I have this is GitHub, and I'm just going to click on this Collab button. So click here, and that's it. So we have now the ability to open any GitHub repositories Jupyter Notebook in Google Collab. So let's take a look, for instance, at, I don't know, let's do Pix2Pix, Jupyter Notebook on GitHub, right? So we go here, Collab Notebook, right? So we have this one here, so we can click. So this is, let me go back just in case that you didn't see that. So we have this StyleGAN link here. So I'm gonna click, we're gonna open this. So this is like a notebook, add StyleGAN Collab Notebook. there is this opening Collab link here, which is provided for what we're trying to do here. But if you see this is on GitHub, I click on Collab, and we open it in our Collab account. Right. So yeah, this is pretty cool. It's fairly simple. So now we have this test notebook, and we're just gonna run everything. Yes, and that's it. So in a nutshell, that was how to host our Jupyter notebooks in our GitHub repository, and then how to open them automatically on Google Colab. And this is a really good practice if you want to share your notebooks with other people, or maybe just have notebooks that you host the code on GitHub, and that's a way to have your own repository of notebooks, and then easily you can open them in Google Colab and share them with other people. And you can see that this one here is executing. So I'm gonna put the link to this one just as a test on the live streams chat. So this is gonna be links for live 25 bold, and the first link would be sample notebook loaded from GitHub, loaded to Collab from GitHub. All right, so that's the first thing. And the little code snippet for this shortcut here, I'm also gonna put on the repo. So this is, let me just edit here. So Google Chrome bookmark JavaScript to open in Collab. It's gonna be here. All right, and it makes sense that we also put that into here. So bookmark open in Collab JavaScript. We just put this here. All right, where are we? What did I do? Okay, so I have this file here in the wrong place. So let's go, is this it? All right, so we're gonna move bookmark to this 024. Right, and we push. Okay, so this is just like a good practice that I'm trying to comply with and actually put the code. Okay, so that was a good diversion, and now we can go back to taking a look at the what's going on here. All right, training styling Collab. Okay, so we did take a look at this notebook, which has many different parts, and I'm going to go here. All right, so I won't go into details with this, but we managed to train. So you have a few settings or hyperparameters here that you have to configure to make sure that you can download a data set, download a pre-trained network. We saw how to download checkpoints from NVIDIA's repositories, from your own Dropbox account, or even from Google Drive, and how to download a dataset from a URL where you're downloading a zip, and then the notebook will automatically unzip that. We set the experiment directory to where we want to save models, checkpoints, fakes, and files that we generate as artifacts. Then we set the maximum amount of images we want to process from the dataset data. The point where the model has been trained before, so that pre-trained model, and then for how many training KI images to train for. And we can estimate the duration of the length of time that our training set or the training process is going to take by looking at the seconds per million or like 1,000 of images. In this case, you can maybe train in 7 hours. You can train for 100. I don't know. Like you need to calculate. We did the numbers, the math last week. So we create the directories, we download required datasets, we clone the StyleGAN from GitHub, from NVIDIA's GitHub repository of StyleGAN. We download and prepare a dataset. This is a process that requires creating huge files that contain the TF records. From images, we verify those works, we process them, and then we create TF records that can be loaded by TensorFlow when training. And then we define the training loop. We inject a few variables here from our hyperparameters into this training file with this code here, this code here. No, actually, yeah. So we replace the variables with set. I don't know why this went above, but this should be here. And then we customize the training variables, and then we train. After training, or while training, those files that we're training, the checkpoints get saved to Google Colab, and then we were looking at how to generate images. The image generation step, if I'm not wrong, we already copied here, right? I'm not too sure. Python tests. This is probably not it. Okay, so let me just take a look, because I think we created a separate notebook, right? Image generation notebook. Okay, we should probably remove all the stuff that is not for training from the other notebook, because this one is just for actually generating the images. And that's all we're gonna see for like the training style in Collab today, because if you want to see that in detail, that's last week's live stream. That's Nono.MA/live/24. And now we're gonna see or continue seeing how to generate images with StyleGAN. We're at 8:46, so we've been online for almost 50 minutes now. And I want to hear from you. I want to hear on the chat or on the Discord server if you have any comment. Hopefully we'll get to like a midpoint where we can have other challenges or other tutorials that are a bit more for beginners or for people who don't know how to code or how to do these sort of things. All right, so I'm going to take a quick break, and after that we'll continue with the generating images with StyleGAN part. And feel free to write any questions you have on the chat, on the Discord server. So we have the Discord server here. You go to chat, and that's where you have to put your comments. So let me put it. So here in chats on live, and yeah. So that's that for now, and we'll be back in a few seconds. All right, let's keep going. Cool. So let's get out of this break and let's come back to this section. So generating images with StyleGAN. If you just connected, we're going to take a look at something that we were taking a look in Live 24 already, which is how to generate images with StyleGAN with datasets that we already have, or trained models that we already have. So this implies that we've gone through the process of preparing a dataset, training a StyleGAN model, and now we have a notebook, we have some code that can load that model and can generate new images. I do have interest on training more models, but I haven't had the time to do that, and maybe we should prepare some more data sets, but you know, time is limited and I haven't been able to put the time on that. All right, so I'm gonna close some things that I have open. We have the Keynote, we have the Google Collab, and we have this predicting notebook. Let's take a look so we can close all these things. And yes, all right. So image generation. Once again, this is the same notebook that we have here. So it's StyleGAN 2 image generation Collab Notebook. So you can open it at home. You can select a model that is already trained on the cloud and load it. So this is, you know, this is sort of like a lecture of a class. So for the people who are online, I'm giving you the opportunity to let me know that you're online, kind of say hi again on the chat that you're online right now. And we can go through this together if you want to try on your machine. So if you want, I can go at a slower pace, and you can let me know in the chat. So tell me that you're gonna try to follow this exercise, and we'll do that. So I'll tell you where to, I send the link on the chat that you have to use to use this notebook, and I'll try to get together also a link for a model. So everything that we do here also happens on your machine. So that's kind of like the workshop format. In YouTube is a bit hard, but if you are online, I'll be glad to do that. So I'm gonna keep going for a sec, and feel free to drop a comment on the chat or on the Discord if that's something that you would like to do. All right, so let's revisit a bit this notebook again. Collab makes it easy to understand code when the code is small or short, but if the code is as this one that is a bit, it's a bit too much, I think it's a bit hard to navigate through it. But what we want to try to do now, and maybe in other live streams, is to understand what's going on here and how we can tweak all the things that are happening to our benefit. All right, so let's start executing. So the first thing, I open my Collab Notebook, and as a good practice, so let's I won't download it right now because I know I'm gonna edit things, and these two are like linking to each other from here. So we'll probably just be using this one. So instead of using the one on Google, so on GitHub, I'm gonna be using the ones here that you can see with these two links. So this link and this link from links for Live 24. All right, so and maybe, just maybe a good practice for me to do instead of putting separate messages is to do this that I was starting to do today. So I just copy these links here and remove this, and we just have one message for each of the lives. Cool. All right. Cool. Great. So we open the notebook. I'm going to put this on full screen, and I'm going to go to runtime, change runtime, GPU, high RAM. Again, we have a video, or like we have last week's live stream or 2 weeks ago, we have that part of like signing up for Google Collab Pro and why and all these things. And That's a video also I have to edit. So we can click on connect or just start executing a cell. So we click on connect here, and we get a backend allocated for us. So right now it's initializing, and this will tell us what we have when it's ready. So we have, we're connected to Python 3 Google Compute Engine backend for free, right? So this is expensive if we were using it with our Google Cloud Platform account. And we have a GPU, we have 25 gigs of RAM and 147 gigs of disk. I'm really confused on how these resources or this resource allocation works, but you know, that's how it is. Each notebook has its own way of providing you with resources. Once we have this, we can start executing cells. So for instance, on this one, we're simply loading dependencies. We're now mounting Google Drive, which is gonna ask me for a link there. I'm just gonna put this here so I can open my my Google Drive account and provide this with access. So it will give me like a token that I have to put here. I don't know, you need to keep it safe because otherwise other people might be getting access to your Google Drive. So now we can come back. We set our settings. So this is not live 24 anymore. So this is live 25. This is their experiment there. This is where all the artifacts we generate with this predicting notebook are going to be saved to. You know, we still have this thing here saying live 24. Maybe we can say 24, 25. This is also today, so 25. Then network snapshot. This is for portraits. So we have here network snapshot 1547. So we saw that which one this was last week. We're going to see it below. So we execute, we just define two variables. Now we download the dataset if we don't have it, which we don't. So now this is being downloaded here. And you know, the file that got created is being downloaded exactly there. And once this is loaded, we don't really need anything else. So we continue here, create the necessary directories on our Google Cloud account. So I'm going to go to, again, let me just push this for a second. So I'm going to open my Google Drive account in here and get to the right account and open my drive, right? So here I have my drive with my ML account, and then we have object detection StyleGAN. The directory names get defined with this, so ML StyleGAN, and that's what's defining the name that where Google the Collab notebook is going to save the things because of the way that code is created. So we have this folder name here, and if we open StyleGAN, we see that this folder was created and artifacts and models. There's nothing there, but that's you know, that's what was created, and here's where we're going to be saving files. So we're going to keep going. So we ensured that those directories exist. We have some information about the directories here. We go to the content folder, and then we download the Google Colab repository again and go into the StyleGAN folder, and then we run a few MVCC programs to test that it exists and run it. So MVCC test MVCC.q. And this is CUDA programs. We're going to take a look at what this is. Check CUDA error, blah, blah, blah. CPU says hello. And there is also, test MVCC. Test MVCC. So this is probably just loading this file and running it. So this might compile something. I don't really know, but this is CPU says hello, GPU says hello, and that's what this is doing, right? So let's take a look. So GPU says hello, CPU says hello, but we don't get anything else. If we were to try to execute this somewhere else, it probably wouldn't work. So MVC CLI tool. This is the MVCC CUDA programming tool. What is MVCC? Introduction. All right. So the CUDA toolkit targets a class of applications, control part, runs, as a process on a general purpose computing device in which use one or more NVIDIA GPUs as co-processors for accelerating single program, multiple data, parallel jobs. Such jobs are self-contained in the sense that they can be executed and completed by a batch of GPU threads entirely without intervention by the host process, thereby gaining optimal benefit from the parallel graphics hardware. The GPU code is implemented as a collection of functions in a language that is essentially C++, but with some annotations for distinguishing them from the host code, plus annotations for distinguishing different types of data memory that exist on GPU. Such functions may have parameters, and they can be called using a syntax that is very similar to regular C, function calling, but slightly extended for being able to specify the matrix of GPU threads that must execute the call function. During its lifetime, the host process may dispatch many parallel GPU tasks. Alright, and then there's the CUDA C++ programming guide, blah, blah, blah. So this is, CUDA programming. MVCC stood for something NVIDIA. I said this a while ago. So NVIDIA CUDA compiler, alright. MVCC is a compiler proprietary of NVIDIA intended for use with CUDA. CUDA code runs both on CPU and GPU. MVCC separates these two parts and sends host code to C compiler like GCC or Intel C++ and sends the device code to the GPU. Alright, so this is what's going on there, right? You don't need to understand a lot more. We're just checking that we have access to MVCC programs and we have StyleGAN. So StyleGAN now is side by side with our model. We hide this. Again, a reminder, we have this table of contents here because we're using proper headers in our markdown blocks. So this is header level 2 and we have them here. So we just downloaded and tested StyleGAN and MVCC. Now we're going to customize the training variables, which we're not really going to do anything there. We're just going to say that the network we're going to use is the network path that has been defined above by our notebook, so we can gain some space here. And this is loading the network. Loading the network means that we're going to be loading that network to be able to generate synthetic images. And all right, so we have the code here. We're going to see now, these are some helper functions that will execute after the model has been loaded, and we're going to print or generate some images. Right, so the model has been loaded now, and these are just a set of random seeds, right? Random numbers, and each of them is going to be in a specific place on the latent space, and is going to generate a different output. But we can also list a set of seeds by hand, like this one, 5, 1, 18, 78, whatever, and request our model to generate images for each of those seeds manually, right? So here we have, we have this series of images, and we can see that image 5 is going to correspond to this sample. Image 1 is going to correspond to this sample, right? So we can keep this here, and if we want to repeat this image, we can say, okay, 1, 1, 1, and then that image will appear 3 times, right? So it's going to be sampled 3 times here. With this, what we can do is that we can preview the different steps of the latent space that we're sampling, and later generate interpolation videos from A to B to C to D to blah, 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 right? What's cool about this, we can generate many images. We can preview them and see which images they are, or what number or what seed they correspond to, and cherry pick which images we want to sample for a montage or for that interpolation video. So one thing that could be cool is, like, let's say we have this one with long hair and we want to simply put that in between every other sample, right? So we have numbers and then 1, and then number and then 1. And we're gonna do that right now. All right, so we are gonna get, we're gonna get random, like some samples, and then this haired one in between. So we're gonna generate those images again. And what this is gonna do is that it's going to go somewhere and then back there, somewhere and then back there, somewhere and then back there, right? And this one looks really similar, so I'm gonna remove this one. I'm just gonna remove this too and generate that again. And now we can save the individual frames. So we can say, okay, which is the seeds string, which is, okay, it's gonna be the path. We're gonna make that path, and for images, we're gonna save them with the seeds index. So we have these images here. All right, and we just save them. So now here, we're just gonna save the images. So we have our Google Drive, we have the artifacts and the snapshot that we're using. So we now execute this cell. So I'm pressing Shift Enter if you're not familiar with these notebooks. And now we have saved all those files here, right? So we have here the name of the snapshot of the pre-trained network that we're using. We have then the numbers of the seeds. So we have 5, 1, 18, 1, 78, 1, 92, 1, 134, 1, 0, right? That makes it so we can come back and know which images this folder has and regenerate them. So you can see the image first image is 5, second is 1, 18, 1, right? And if we open it, we can see 1024 by 1024 representation of each of these images. In this case, this is a bit silly because every other image is going to be the same. We're wasting resources to generate the very same image, but this means that we have that jump between some phase and then that phase, some phase and then this phase, and some phase and then this phase, right? And now we can generate an MP4 video and save it. We're saving to the artifact saved there with the network name, seed string, and then the name of this video is going to be the same name of this folder with the MP4 with this suffix, right? The CS from seeds MP4. And this is something that I've done before, and I'm not I'm not surprised, but I think it's really awesome that we have this level or this grain of control for what we can generate and how we can generate from a model that we have trained already. This is probably now saving that. More complex example, interpolating in W instead of C space, right? We are gonna try to understand these things now, right? I'm gonna try to understand a bit more the Z and the C's and the W's. That is something that I think would be worth looking at. And then here we have this video. So let's take a look at this interpolation video. So we go to a face and then to that one. We go to another face and then to that one. Face, that one. Face and that one. And you can see, there are some images that are farther from that latency base point where the one with the long hair is, and then there are other images that are a bit closer, right? Let's actually do one thing. Let's actually go to Twitter and put some teaser of this live thing that we're doing. Can we turn this into a GIF in less than a minute? Maybe. Can we? And it's the GIF smaller than 10 megabytes or something that we can upload to Twitter? Yes. Oh, no. Yeah, probably not. So I might have to put less frames per second. So maybe 4. Let's do 3. And then the GIF is gonna have maybe 6. Yeah, so the frames are not big, and I don't know if we're jumping too much. Yeah, we're probably jumping too much. Yep. Yeah, so the problem here, so let's try to make it once more. Let's just give him one more try. So we're gonna do the frames, which is gonna be 10 frames per second, maybe even more. So 15 frames per second. So we create a bunch of images, but we're just gonna choose one of those interpolations. So we go from this one that seems to be the midpoint. So this one, so we wanna probably start on this face and then go somewhere else and then come back. Right, let's make that on purpose. So how do we do that, right? So the way to do that would be to, instead of starting here, starting with the same face that we wanna end. These two look really similar, so maybe we can skip that process of re-exporting, just grabbing this one here. So you have 92 frames, and we're gonna make a GIF, and it's gonna be maybe, let's make 20 frames per second. Yeah, and that folder with 2 megabytes of photos ends up being a huge GIF. All right, so let's actually make it here. So we can go from, let's sample more images. Let's just sample more images and try to do that I was mentioning. So let's just put here maybe a new set of seats, and we're gonna do maybe one. Okay, so Python generate series numbers. Oh, just that? Okay. So let's just try quickly. Okay. Is that an array? List. Okay. Great. So just with this, we can make a list. So let's make a list of a range from 0 to, well, let's try first with 20. So we generate the image now. So this is generating 19 images or 20 images, I think 19. And we can see that here, right? So we have all these people here. Right, so what is this one? So this is 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so that should be 14. So what if we just do seeds equal 1, 14, and 1, and then 0. We need to pad at the end because for some reason the last one doesn't get generated. All right, so that's that. I don't like that we have this thing here. I don't know if that can, any of the others don't have it. Then just take a quick look. All right, so maybe this one. I mean, this one doesn't have that much. Well, let's try with 12. All right, so let's try with that. So we now can save all the individual frames. We won't do that. We're gonna save the actual video. And this should be really fast because it's just 30 frames. It's 15 frames per second, I think. So that gets saved here. It will be saved to my Google Drive. And you know, the only thing you need to pay attention here is like it's going to be the same name, so network snapshot, and then 12, 14, 12, 0. Those are the seeds that I've used in here. So that's here. It's 12, 14, 12, 0, right? And we can download this one. So download that. And that is here. That way we make sure that we also don't have many files with the exact same name or something. Each name is unique because it's the model name, and the seeds and stuff. So all right, so we do, let's remove the frames folder. So we do get the frames. So these I'm using FFmpeg to extract the frames, and then ImageMagick to make the GIF. And hopefully that works well, and it's not that. Wait, is this the last one? Yeah, that is weird, right? So it's indeed going to 0, and I'm not sure why that is. So we probably need to remove the 0 from here, even if we don't preview it, right? Like we won't preview the last image. I see. All right, so let's try that. So let's see if this actually gets generated. Because I want a way where I can visualize all the images, but the video doesn't generate with the 0, because the 0 doesn't seem to be like, well, I mean the 0 or any number. All right, so that. Okay, I think that makes it. Let's try. So let's try now frames. So let's remove the frames and make the frames, and then make the GIF. Right, and we could, we could increase these the speed. Maybe too much. Right, let's do 20. Right, well, let's do that. Okay. All right, so let's keep going. So we've seen how to generate videos, and there's a concept here that I want to touch on. Maybe we keep looking at this next week. Maybe we have time for it today. But there is something called the Z vector and the W, I think it's W vector as well, in here. So generate images in W space, and then there's also Z space, right? So StyleGAN W space, StyleGAN Z space, right? Okay, so Z space, let's just see. W to be less entangled at Z space, right? So, okay, mapping network F. The major reason for this choice is that the intermediate latent space W does not have to support sampling according to any fixed distribution. With continuous mapping, its sampling density is induced. This mapping F unwraps the space of W, so it implicitly enforces a sort of disentangled representation. This means that the factors of variation become more linear. The authors argue that it will be easier to generate realistic images based on a disentangled representation compared to entangled ones. With this totally unsupervised trick, we at least expect W to be less entangled than Z space. Let's move on to the depicted A in the figure. Network G, style mixing. Right, so here we can actually try to go, and I guess this is W. I don't exactly know. It's interesting that very high level attributes often flip between the opposite, including viewpoint, glasses, age, coloring, hair length, and all right. So another trick that was introduced in the style mixing, sampling two samples from the latent space Z, they generate two intermediate latent vectors W1, W2 corresponding to two styles. W1 is applied before the crossover point and W after it, W2, to perform inside the block. This regularization trick prevents the network from assuming that adjacent styles are correlated. A percentage of generated images, usually 95, use this trick, and it is randomly applied to different places in the network every time. Alright, let's take a look at that graph here. So we have the latent Z, the mapping network F, and then we have here the W vector G. Right. I would, this is something we need to take a look in depth at the paper to understand better. But in short, we have, we have two vectors. There's a Z vector that has 512 components. So we can do here live, and let me see where we have that. So we probably have some, I think we probably have some of those from other tutorials. Maybe not. Yeah, I might not have it here. Yeah, here it is. Okay, great. So this is a like a 512 component vector, which is ranges with values, I think, from -1 to 1, and or actually, I mean, I cannot see anything that's greater than 0.5, to be honest. So it might be from -0.5 to 0.5. I cannot see anything greater than 0.4. Oh, 0.5, 0.4, 0.6, 0.7, 0.5. Nothing greater than 0.4 here. Okay, yeah, 0.5 is the greatest here, 0.55. But yeah, those 512 elements our input into the network, and then they generate a specific image, each of those frames that we have there. And what I'm trying to do here before we go is take a quick look at how we can see the actual input C and generate these from seeds. Okay, so let's try to understand that function. So we can get a code block here. So we have generate C's from seeds, and then we're gonna put here 3 seeds, 0, 1, and 2. Right, so we have here, as I mentioned before, we have an array of Z vectors, right? So we take a look, so this is 3 components. If we get the first one, so let's just say that we just get 1. So we get the first one, that's an array. And if it's an array, we might take a look at its length. I don't know if we can. It's 1. Okay, so maybe we need to go in depth. Okay, 512. So we have 512 components in this Z vector. And it's not easy to understand what each of those components of this vector are doing to the output generated image, but let's see. I mean, let's try to understand it. So we have the first, for seed number 0, we have all these values. You see here there's a minus 1.6, 1 point something. And one thing we could do, I don't know if we can do just max here. Yeah, so the max is 2.69, and so let's try to get here. C is this, so the max and the min. Okay, print. So max and min, so go from 2.7 to minus 2.8, more or less. All right. And what we have there is, let's see, I'm not sure if I can print the shape, because this is not a NumPy array, right? So 512. Okay, so we have 512, but what we're really getting, so we do this, we get a list, because it's a list. So we're gonna get the first item, Z shape, and I'm not sure why we're getting, okay. So let's just print that. Okay, so we have the shape, which is a batch of 1 and 512, but if we put here some numbers, okay, we get the first one. All right, so we have a set of tensors that are like a one-dimensional tensor that has 512 components. So we could, let's say, we could make our own Z vector by, let me just do, let's see what this is. Okay. So we have an array and this. Well, let's see here. All right, so let's see. So if I do here, so we have an array. Okay, I think we have this function here. So okay, generate Z from C. So we enumerate the seeds. We have the seed index and the seed, MP, random state, seed. Okay, and then random it, GS input shape. mini batch component. Okay, so okay. Okay, so my doubt is, can I generate these C's manually without having to take a look at, so to use this function, right? So that's what I'm trying to see, because I would love to control those individual components manually before we wrap up today. So we could have a, so how do we make an array? Create an array Python. What? I mean, a list. Okay, but an array, how do you, it's just a simple, okay, so does this have a shape? I don't understand. Why is that Python get type of object? List. Okay. But if we do this, we do get the Z is a list, but then the first item of the list is a numpy ND array. All right. So we can do NumPy array of this, right? And then we get the shape is 1. So we can actually do this, which is 1, 1. And then we can do this, which is 1, 4. All right. So here we can get a list of range from 0 to 512 or that. All right, so now we're talking. So the start, okay, range Python. Okay, so we have here, so let's just start with 12. Great. So we are trying to generate a z vector on demand, let's say, with the values that we want. So we're gonna print here. So this is gonna be custom z's. It's gonna be print custom z's shape and print custom z's. Right. So this is what we have right now, and we want to go from like with small values, right? So I'm not sure if I can, for example, do this. So all right. Great. So we could okay, can I do here minus 1 to 1, and the step is 2 divided 500. All right, and yeah, let's see. So I'm gonna try to see how we can range from -1 to 1 in 500 steps. All right, so this seems to be working. So we have from -1 to 1, we have 512 components, and we're gonna try to generate an image with this Z vector now. So at least generate a few images, and I want to take a look at how we're saving. So this is convert Z to W, generate Z's from seeds. How we can generate images? Are we generate images from generate images, interpolate CS number? All right, so MP3, MP4 movie. So let's take a look. Let's put this above. So let's take this up, and this is how is it generating images? Generate images, interpolate latents, number of steps. These, okay, so we are actually getting these here, and we could do this manually. So all right, let's take this cell up and put here some text. So this is creating images from custom Z vectors. Right, so we have that. So the Z's are here, generate Z from seeds. We don't really need this. So this, we just need a list of these things. All right, so what we're gonna provide is so we have this, so this works, and we're gonna put this like this. And so this, we have like a one-dimensional 512 component vector, and we could now, because we have the C's, we could now say, okay, those C's are latents, and we're going to show the images that correspond to that. So our latents are now the custom Z's, and we're going to generate images, interpolating, create image grid, and that's going to be it. So custom Z's is going to be, you know, this. All right, and okay, I can see some familiar faces on the chat. Hello, Lourdes. And I am going to generate images from this. Okay, so this is the image that corresponds to the to this custom vector that we've coded in here. Let's make another test. So for example, to have two different ones that we've done by hand. So let's just maybe move this a bit, and we just need to put some padding here. And yeah, okay, we have that. So let's try to maybe just move it a bit less, a bit more. Okay, so here we're getting somewhere. I don't know where, but we're getting somewhere. So we are moving slightly on like a, so let's say we're gonna iterate through this from 1 to somewhere, right? So we'll leave, let's do for I in range 0 to 10, for example. So we're gonna have the latents is a list, and we're gonna say, okay, custom CS equals mp dot array, and we're gonna make a list from range 0 to 512, and then after here we're gonna multiply by that factor, and we're gonna remove I multiplied by 0.1, right? Yeah, so that would be on our latents append custom Z. Right, let's see what that does for us. Right, so we're creating a set of images interpolating from one to the other. That's pretty cool. And you know, this means that we're moving on some direction on the latent space by removing numbers, right? and we could do it in a more fine grain or like bigger steps. Probably right now we want to do it in bigger steps, so let's go at double the speed, let's say. So we go from here to here, and maybe we can put like 30 steps and go slightly faster. Let's keep it at the same pace. All right, cool. So maybe, yeah, I don't know, when we go down that path, it seems like there is a lot of prominence to this point. So let's probably +1. Let's just move it a bit. Cool. Okay, so we're, let me just make this a bit faster. And there. And if we invert that, well, we just get everything almost the same, right? Right, we actually go from one stream to the other. Okay, so yeah, I think this is pretty cool. So I'm gonna quickly take a break, and we'll be back to wrap up really soon. Okay, so we're gonna be wrapping up really soon, but I'm liking that we got to this point. So this is a, we need to do some more work to understand what exactly is going on in here. In summary, we're just creating by hand the vector that makes or produces these images with the synthetic StyleGAN model that that we're producing this with. There are things like here, for example, I think like number of steps, create image grid, number of steps 1. So if we were to, for example, like increase this number, the interpolation might be greater between those. So we're just generating the image. These are the images from the Z vectors that we're generating, really. Right now we have a vector that moves at the same rate all of its parameters, and we could do a bunch of things. So for example, if we put like a 4 here, I think that might change a lot as well. But there is not, it changes a bit from what we had before to what we have now. And there's a lot of things that we need to understand from here. The only thing that we can do just to test this code with something slightly different is changing the network path. So the network that we're using, instead of the faces, use a different model. So I'm gonna go ahead and grab one of the links from the models that I have on Dropbox. Right, so I'm just copying this link. So create a link, copy the links from one of these models, and actually I already have it here from 82. Okay, we can put another one here. So network there, and that's it. So I'm gonna rerun all these cells that reload the model, and then up to we get to the one that we were doing to generate the custom latent space. And what we can get here, I mean, it's a model. What I'm trying here is that we have a model that has more knowledge. Let's say the portraits model is only trained with 10 sketches, but this one is trained with 70 something, I think, 70 something distinct ones. So right now we are loading the model. Let's see where we are. Yeah, so you can see that the model is working. And then we have this here. And you can see this is pretty cool because it's the interpolation of the network is evident, and we can see a lot there that not a lot is changing. Let's say we could put like a bigger step to see if this changes a bit more. Right. This is really weird, but yeah, it's really hard to understand what each of these components is doing. I'm trying to figure out like if we could maybe have the same vector, so the same tensor or the same array, and just change one component. So let me try to just put here maybe 6. And so these are 6, and maybe let's make 9 so they're a bit smaller. So you have 9 images here, and what I'm gonna do, I'm just gonna make them all be the same. So these are gonna be the same images. All right, and maybe we can change a bit here. If we move this, so we move all the components at 1, 3. It doesn't really change that much. So if I do this, all right, so we just keep getting different things, right, as we move. And what I want to try to do is, instead of changing the entire set of components of this network, maybe just change one. So let's say that we do custom Z for in range 0 to, I don't know, maybe 64. We're gonna change custom Z. This is an array, so we're gonna change for 0, and then component I. We're going to multiply that by I, or like maybe add I. All right, yeah, let's do that. Okay, so we're doing that in every component, but what if we only changed until I multiplied by 10? So this is going to be J. Okay, what property are we changing now? But definitely is radically changing. So let's see here. Okay. So maybe let's only change 10, but change them exponentially. Okay. What is happening here? So we see these blobs here that keep kind of looping back and forth. And maybe the nature of making them. Okay, so we're changing the 10 first components. I was making a mistake here. So changing the first components. All right. Nice. So awesome. So this leads me to somewhere, right? So if I yeah, this is really weird, because we are right now we're like taking a look at, let me see, so start point is here 20, for example. So start point plus 3 or 4. And you know, if you're still with us, if you're still watching, what we're trying to do is, you have 512 components, and we're trying to just change a few things from these 512 components, only specific components of this Z vector that has 512 components, and see how the network changes, right? So let's see. In this case right now, so let me just go back to 10 to see if we have what we had before. All right. So we can make actually like for x in range 0 to 10, we're gonna make this be here inside, and we're gonna put that x is here, and we're gonna see what happens. All right, and maybe, yeah, I think this amount of images is good. Right, let's see if we generate many of this. Cool. Okay, this is I think what I wanted to see. Cool. So we're generating some sort of matrix in which we're exploring how modifying the different parts of these 512 component input array or vector changes the drawing. This is pretty interesting. We're getting like a ton of variations which look really similar because they all have this blue. As you can see, from some of them the text varies a bit where the text is, and right, let's see what we can do to change this a lot. So if I do, maybe let's put some hyperparameters here. So right, so these are here. So what happens if we put this to be 1 and this to be 5? That's pretty weird. I mean, I really want to understand what's going on. And I think it's going to take me some iteration. But what you can see here is that this network is able to generate many more things than what we've seen on previous videos. I think this is pretty awesome. And now we go to these weird things. Okay. So from 0 to 10, and so we're just changing, so from 0 to 10, from 1 to 11, it's changing like really few of the lines there. I guess we could increase this. So this could be multiplied by 3 to go faster. Yeah, this is pretty impressive. So my interest here, like right now we're changing 10 components at a time, right? And maybe seeing too many images for each of these. Let's just say that we do 6 and then we do 3 to make to speed this up a bit. So what's going on here is that we're now changing. Okay, so we're now changing 10 components at a time. But what if we just change, let's say, 1 component? How how does this change, right? So yeah, so here, yeah, I have no idea what's going on. Okay. Yeah, so I mean, this has been like an exploration, a bit of learning for me. I want to learn more about the W vector or input. And what happens here is that when you have the StyleGAN model, it can, or in some way maps features from the face to these components, right, on the W and the Z space. And in this case, I would be curious to see if we can end up mapping, like have more labels or less, or more color of blue or less, or things like this to specific components or ways of modifying the latent space of this input Z vector. But yeah, so this is all for today. I am gonna check the thumbnails, just make sure I do that and upload that here. And I won't schedule the live stream for next week because I don't really know if we're gonna be able to have one next week. But yeah, so hopefully we do. If not, I'll see you all in 2 or 3 weeks. Right, so let me get back at this image. Right. All right, so we're also seeing this, and that will be it. So this is, oh, I don't know what that is. That was meant to be done. All right, so we save. This is what you see when this is live. You just need to wait for that to save. Right. Great. Okay. Thanks for being there. I would just remind you really quickly that liking the video helps a lot, because that helps support the channel and for other people to find the videos. And if you're not subscribed yet, you can subscribe if you want to get notified when I go live next or when I upload new videos. Join the community. You know, I've repeated this many times. You can join us at Discord. And yeah, thanks so much for watching, and we'll see you next time. I'm always eager to hear from you. I'd love to hear your comments, your suggestions, your questions, and whatnot. So once again, this is your host, Nono Martinez Alonso, and I'll see you next time. Bye.